Well, hello. I'm going to do 5 extra Half-Life problems, just in case you need a little extra help or you're confused. So don't forget we said that yesterday, if this is our original sample, after 1 half-life, we have half remaining. If we cut that in half, we have 1/4 remaining. If we cut that in half, we have 1/8 remaining. And then after 1, 2, 3, 4 half-lives, we would have 1/16 and then 1/32 of the original sample remaining. So this is 1, 2, 3, 4, 5 half-lives. Okay, and don't forget we said that our useful equation is the total time that has passed over the half-life of the substance is equal to the number of half-lives that have passed. And of course, we can put that over 1 if we need to cross-multiply. All right, let's get this party started. First one, an 80 milligram sample of a radioisotope decays to 5 milligrams in 32 days. What is the half-life of this element? So I'll just start by putting total time over half-life equals number of half-lives. Okay, so the total time that has passed is 32 days. And I want the half-life. And in order to solve for this, I need to first know the number of half-lives that have passed. So I started with 80, I ended up with 5. I could figure out how many half-lives have passed. So 80, half of that's 40, half of that is 20, 10, 5. That means that 1, 2, 3, 4 half-lives have passed. So number of half-lives is 4. If I cross multiply, 4x equals 32. That means the number of half-lives, or the half-life, sorry, is 8 days. All right, next, what is the mass of K42 remaining in a 16-gram sample of K42 after 37.2 hours? Okay, total time over half-life equals number of half-lives. Total time is 37.2 hours. And now they gave me an isotope, so that means I need to look up its half-life on table N, which I have in front of me, and the half-life is 12.36 hours. So once again, I got that from table N, the reference table. And from here, I can figure out the number of half-lives. So that equals number of half-lives. And if I divide that, that means that 3 half-lives have passed. And I want to know what's the mass remaining in a 16-gram sample after 3 half-lives have passed. So 16, half of that is 8, half of that is 4, half of that is 2. So I started with 16 grams, and after 1, 2, 3 half-lives, 2 grams remain. So for this one, right, I had to determine the number of half-lives and then use that to figure out how much of this sample would be left. All right, number 3. After 30 days, 10 grams of a radioisotope remains from an original 40-gram sample. What is the half-life of this element? Total time over half-life equals number of half-lives. The total time, so after 30 days, over the half-life, which I want to solve for, and I need the number of half-lives so I can finish my equation. So I can determine what the time for 1 half-life is. So there's 40 grams, we're left with 10 grams. How many half-lives have passed? 40, 20, 10, that's 1, 2 half-lives. So I can plug that into my equation. 2 half-lives have passed, and 2x equals 30, which means that the time of one half-life is 15 in units. I should be using 15 days. Number 4. A sample of iodine-131 decays to 1 gram in 40 days. What is the mass of the original sample? Total time over half-life equals number of half-lives. So the total time was 40 days. I am given a radioisotope, so let me look that up on table N. And the half-life for iodine-131 is 8 days, more or less, 8 days. So that means that the number of half-lives that have passed is, if I divide that, 5. Okay, and I want to know what's the mass of the original sample. So I need to go backwards here for 5 half-lives. I was left with 1 gram, but 5 half-lives have passed. So 1, 2, 4 grams, 8 grams, 16 grams. Let's see, I've done 1, 2, 3, 4 half-lives. I need 1 more, which means that the original sample had 32 grams. And 1 more. What is the total mass of radon-222 remaining in an original 160 milligram sample of radon-222 after 19.1 days? Okay. Total time over half-life equals number of half-lives. Okay, total time, 19.1 days. What's the half-life of radon-222 according to table N? It's about 3.8 days. And if I divide that, that means that 5 half-lives have passed. And I want to know, okay, if I started with 160 milligrams and 5 half-lives have passed, how much would remain from that original sample? So 160 milligrams, 80, cut that in half, 40, 20, 10, let's see, 1, 2, 3, 4, I need 1 more, 5. So that means after 5 milligrams, after 5 half-lives, starting with 160 milligrams, 5 milligrams of the original sample would remain. All right, if you need me to do more practice problems, hit me up and I will do more for you. Otherwise, complete the pod. It's 8 questions today and that's it. Goodbye.